Everyone, this is the part 5 of Higgs coupling, where we will discuss asymmetric version of this coupling and when tandem reactions are possible. The previous videos links you will get in the description box. So normally we do not think about asymmetric version of Higgs coupling, because if you look at this general structure, suppose we have carbon I and CC double bond, and here we have this CC bond formation like this. So here we are not getting any new sp3 carbon, because here this CC double bond, that is the initial CC double bond, it is ending up at its original position. But sometimes it may happen that this initial CC bond, it is not ending up at its original position, and in that case sp3 carbon generation is possible, and then asymmetric version is also possible. So let's start with example 1. In this case we will generate asymmetric tertiary center. So first of all, this is the Ci bond, and let's do the numbering. This is 1, 2, 3, 4, 5, 6. So this is the CC double bond which will take part in Higgs coupling. So this is the 6-1 carbon, they are now connected, and we are getting a 6-member ring. So in this case, if you see, this is the original CC double bond, but it is not ending up at its original position, and that is why we are getting a new chiral carbon, and in this case generation of asymmetric tertiary center is possible. Here it is also mentioned that desymmetrization of a quaternary center. That means if you look at this quaternary center which is present here, before the reaction it is not chiral, because both sides there is equal substitution, right? But after that, after this bond formation, this is a new CC bond formation, now this center is also chiral center, and that is why we are saying it is desymmetrization of a quaternary center. So in this way we are getting chiral carbon, and one achiral carbon is also becoming chiral after the reaction. Next example, heterocycle generation. So in this case, first of all, this is a carbon halogen bond, 1, 2, 3, 4, 5. So in this case, this is the CC bond which will form, and after that this CC bond that will be shifted here. Fine. And if it is shifted here, it will be, so this is the nitrogen. I am not drawing the full structure. So this is CC double bond which is shifted now, and here this OSI bond, now if you look at the reagents, finally it will be converted to OH, and this is enol. So this enol, finally it will be converted to keto. So that is why we are getting C-CHO bond here. But what is the important point here? The important point here, as the original CC bond, it is not ending up at its original position, it is shifted. As you can see, after the CC bond generation, this double bond, it is shifted. And why this shifting is happening, details of it I have already discussed in the previous video. Please watch that, you will understand it. I am not repeating the same thing here. So as the CC bond is shifting here, we are getting chiral center here, and finally this enol, that will be converted to keto form, and that is why we are getting this type of structure. Next example, synthesis of steroid ring system. Sometimes what may happen, so this is the example of tandem reaction. Fine. So when this tandem reaction is possible, and here we are getting steroid ring. If you look at the final structure, this is a steroid ring. Now when it is possible, if there are no hydrogen oriented properly for elimination, or sometimes it may also happen that elimination is not possible because of the lack of beta hydrogen, or maybe some other reason. Whatever it is, if it is not possible, then what will happen? If there is some, if we look at the environment, if there is properly situated CC double bond or triple bond, then the alkyl palladium species which is persisting, because the beta elimination is not possible, so this alkyl palladium species, it persists and it can participate in subsequent reactions, but provided there will be, we have to look at the environment when there is presence of CC double bond triple bond, then it is possible. So here if we look at this initial starting material, this is a Ci bond. So here we will first get PDI, and after that this is the first generated 6-member ring. But after that, the PDI that will be shifted in this triple bond. Now it will no longer be a triple bond, it will be double bond and PDI. And here elimination is not possible. So this will be now doing another Heck reaction, and that is why we are getting the next CC bond, next CC bond and 6 member ring. Fine. And then the PDI, it will be now become CC double bond and PDI will be shifted here. We are getting the next 6 member ring, right? And after that, the PDI, now it will be CC single bond and PDI will be there. And finally, the ring is closed. And this PDI, it is now shifting to this CC, which is terminal CC double bond. It is now no longer CC double bond, it is single bond. So this is a single bond, then PDI. And finally, there will be elimination of hydrogen. And we will get this CC double bond, which you can see here. So in this way, total, not just one time, but because of the presence of the double bond, CC double bond and triple bond suitably present, not just merely present, then further tandem reactions are also possible. So these are the conditions for the synthesis when we can get tandem reactions. Example 3, next example is 4. Now in this example, we will see not just tandem reaction but also asymmetric ring generation. So here we have COTF, and this COTF, if we are numbering the carbon 1, 2, 3, 4, 5. Now it is endo, it is not exo, and related to endo exo also there is a separate video, you can watch it, you will get all the links in the description box. So if it is now connected here, what we will get? We will get a 5 member ring, and if I am doing the numbering 1, 2, 3, 4, 5, right? And if this is a 6 number carbon, now with this 6 number carbon there will be this palladium species, suppose I am writing here 6, and this chain, which is total 4 carbon chain, 1, 2, 3, 4. Let me use another color. Now suppose it is 1, 2, 3, 4, 5. So we have already obtained one chiral carbon, but as there is another CC double bond, so further tandem reaction is also possible. So this 6 carbon and 1, 2, 3, 4, 5. So this will be the connection point. And finally this PD species that will be ending up at this position. And further removal of hydrogen, we will get CC double bond at the terminal position. So what we are getting? We are getting, this is the original 6 member ring, it is not disturbed. This is the first generator 5 member ring. And now spiral center, we are getting another 6 member ring. I am doing the new numbering. What it is? 1, 2, 3, 4, 5. So it is originally it was 6, but now it is 1 for the second reaction. So at 1 and 5 we are getting a new ring, and finally there will be a CC double bond. Okay. So in this way we are getting asymmetric center here, and also there is a tandem reaction because of the presence of another CC double bond. Example 5, tandem Heck carbonylation. So this is our Ci bond. Let me do the numbering. 3, 4, 5. So 1, 5 bond that will be now connected, and finally the PDI that will be shifted here. Okay, but in presence of this CO and also this alcoholic co-solvent which is MEOH, there will be carbonylations. There will be first CO insertion, and in presence of this MEOH, finally with this carbon we are finally getting, this is the carbon, the previous one, this one, and finally we are getting from CO and methanol we are getting this type of ester. So this is why this is under tandem reaction, because after the first Heck reaction, further there is CO insertion happening. Why? Because of this reagent reaction condition. Okay, so that is the example of tandem Heck carbonylation, where the tandem reaction is some carbonylation reaction, and in presence of alcoholic co-solvent, we are getting S star CO2 Me. Tandem insertion and heterocyclization by nucleophilic atom. If we look at the starting material, we can see there is a conjugated CC double bond. And this molecule we will draw in such a way so that we can understand the Heck reaction in a better way. So that's why just draw the same molecule. This is the same molecule. The same molecule I have drawn in a different way. So what I have done, this part I have kept same. Only this below part, as if I have brought it above. Why it is so? So that this Ci bond, now it is close to this Cc double bond. That is the reason why it is drawn in a different way. Now this Ci bond, 1, 2, 3, 4, 5, 6. So this will be the connection point. That means we are getting a new 6-member ring by the connection of carbon 1 and carbon 6. And this Cc bond, now it will be converted to PDI. Now if we focus on this part, this is a pi allyl system which is electrophilic. And in this electrophilic part, this OH which will behave as nucleophile. So what it will do, now let me do the numbering again. 1, 2, 3. Now there is already 1,6 bond, CC bond, 3, 4, 5. So there will be nucleophilic attack to, basically it will be pi allyl palladium species, suppose like this, and this oxygen that will attack at this position, and finally we will get a 5-member ring. So this is the first generated 6-member ring. This is actually, after that, from this you can get this one. So this is the first generated 6-member ring. This is a 6-member ring. As you can, if you follow the numbering, this is 6-member ring. And after that, this OH, this is the palladium, allyl palladium species, and this oxygen, it will attack here, and we are getting this 5-member ring. So this is a 6-member ring, the first form, and the second one is 5-member ring. So this is also the example of tandem Heck insertion, and the second actual tandem step, that is the attack of this nucleophilic OH, I mean oxygen, to this electrophilic pi allyl palladium system. And that is possible because we have this conjugated system. So the first CC bond, it is taking part in the Heck reaction, and after that there is nucleophilic attack to this pi allyl system which is generated because of this second CC double bond. Okay, so that's all about this video, where we have seen how chiral centers can be generated by Heck reaction, intramolecular Heck reaction, and also when tandem reactions are possible, and we have also seen the combination of these both. I hope this video will be helpful to you. Thank you for your time.